Hello guys, we are back here with another video. We are asked to evaluate this integral from 0 to pi over 2 dx over 1 plus tangent of x to the power of pi. So this integral looks really weird, but as we work through, you will see that it gets pretty simple, as we already know some things from the first video, for example. So let's get started. Okay, this integral equals to an integral from 0 to pi over 2 dx over, like tangent of x is just sine over cosine, so 1. So okay, so 1 plus sine over cosine of x. Can write it together to the power of pi. Okay, so when we multiply the things out, 1 will be multiplied with cosine and cosine will flip up, so this equals to is from 0 to pi over 2 cosine of x to the power of pi over cosine of x to the power of pi. Okay, let me write it better. Okay, cosine to the power of x, cosine of x to the power of pi. Okay guys, sorry. I will just write like cosine of x to the power of pi plus sine of x to the power of pi. Okay, when we write this, like in the first video we did something with minus x substitution over the symmetric interval, and then we added the integrals. But here it's something similar. So cosine of pi over 2 minus x is sine, and sine of pi over 2 minus x is cosine. So what we can do here is to invent a substitution. Pi over 2 minus x equals to t. This is negative dx equals to dt, dx equals to negative dt. Okay, and now this equals to what? Integral from what? If we plug pi over 2 here, we get 0. No, we get 0, yeah? If we plug 0 here, we get pi over 2. Like when we plug this into the cosine, we get sine. That's why we did that. Okay, sine of t to the power of pi over sine to the power of pi t plus cosine to the power of pi of t negative dt. Okay, this equals to, we will use this negative to flip the boundary, so we get an integral from 0 to pi over 2 sine of t over sine of t to the power of pi, also here, plus cosine. Okay, this s looks weird. Okay, and also this, plus cosine of t to the power of pi. Okay, so what can we see now? This integral looks really similar to this one. The denominators are the same. So what we can try is to call this integral I, and to call this integral I, and add them up. What will happen? So I plus I equals to 2I, which equals to an integral from 0 to pi over 2 sine of t to the power of pi plus cosine of t to the power of pi over sine of t to the power of pi. Okay, this looks weird. Sine to the power of pi plus cosine of t to the power of pi dt. Like, I just use a different variable. You can make a substitution here, x equals to t, and that's the same. So this obviously gets cancelled out, and we are left out with an integral from 0 to pi over 2 of 1 dt, dt, which equals to t from 0 to pi over 2, which equals to pi over 2. But this isn't the answer. Right? We have 2i, 2i equals to pi over 2. We need to solve for I. So 2i equals, okay, this looks weird again. 2i equals to pi over 2. When we divide both sides by 2, we get I equals to pi over 4. And this is our answer. So guys, that was it for this video. I hope you enjoyed it. Like, share and subscribe if you want to see more of this. And see you in the next video. Bye.